Our Sun is located near the edge of the Milky Way. It travels at a speed of 220 kilometers per second, orbiting around the center of the Milky Way. The Sun completes one orbit around the center of our Milky Way. It takes about 240 million years. Furthermore, in our universe, no object is completely stationary. All objects are constantly in motion. Within our observable range, we can see the Moon orbiting the Earth, the Earth orbiting the Sun, and the solar system rotates on the Orion arm of the Milky Way. Next, we can observe movements on a larger scale. The Milky Way itself is not stationary. It, along with other galaxies, drifts in the vast ocean of the universe. Objects like stars, planets, and nebulae within the Milky Way all revolve around the center of the Milky Way, which is known as the core of the Milky Way. The movement of all celestial bodies is driven by a massive gravity in the universe, like a silent monster, continuously pulling all objects towards its center, attracting them. This gravitational monster is known as the Great Attractor, and is one of the main reasons for the motion of galaxies, despite astronomers never ceasing their exploration of it. Until now, we still know nothing about its nature. However, one thing is certain. In the universe, gravity is the only force influencing the movement of celestial bodies, and the formation of cosmic structures, whatever force it may be, in influencing the movement of objects around Earth. It is surely immense and relentless. It may have a frightening impact. So, can our current scientific research on Earth uncover the truth behind the Great Attractor? Will this mysterious force eventually lead to the destruction of our Earth? Today we will unveil through a scientific perspective the Great Attractor that governs the movement of all celestial bodies in the universe. What exactly is it? First, after the Big Bang in the universe, the entire universe began to expand at an extremely fast speed, and this expansion speed continues to increase. All galaxies are moving away from each other at a speed of about 2.2 million kilometers per hour. Away from each other. Although galaxies are moving away from each other, their speeds of movement are not the same. Some galaxies may slow down relative to other galaxies. This is because they are attracted by the gravity of other galaxies, thus slowing down their movement speed. From this, we can observe galaxies are attracted to each other due to gravity, and gather together, forming larger structures, such as clusters and superclusters. Although there is a gravitational attraction between galaxies, their movements and speeds exhibit some unusual characteristics, different from what we initially expected in theory. Meanwhile, all galaxies around the Milky Way seem to be moving in a specific direction, showing a collective motion trend. In the most secretive places in space, there exists a massive gravitational anomaly. It has been pulling all galaxies near us towards it. We call it the Great Attractor. This mysterious space region may be one of the most terrifying phenomena discovered in the vast universe up to now. According to observations, astronomers believe the Great Attractor is located in the gravitational center of the Laniakea supercluster, and our Milky Way galaxy happens to be within this cluster of 100,000 galaxies. However, despite having advanced space equipment and technology, astronomers still cannot easily explain the existence and impact of the Great Attractor. To truly unravel the mystery of the Great Attractor, the key is for us to understand its origin. In the 1970s, astronomers were mapping cosmic microwave background radiation in detail. The existence of the Great Attractor was first discovered. Astronomers, while creating a detailed map of cosmic microwave background radiation, they discovered an interesting phenomenon. The cosmic microwave background radiation on one side of the Milky Way is slightly warmer than the other side. This indicates the Milky Way is moving at about 370 miles per second through space. Measuring the speed of galaxies is a relatively easy task. But the real challenge lies in explaining the motion direction of these galaxies and the reasons behind it. To solve this problem, the most direct approach is pointing the telescope towards the Great Attractor for observation. But in reality, this is not an easy task. The reason being, the direction where the Great Attractor is located happens to be in the direction of Centaurus, while our Milky Way's disk just happened to block a part of this area, making it even more difficult to observe the Great Attractor. However, in the late 1990s and early 2000s, the Parkes Observatory in New South Wales, Australia, radio telescope, made groundbreaking advances in the field of space. This telescope has an unprecedented level of sensitivity, capable of detecting a large number of galaxies that we usually cannot observe. Through this telescope, astronomers are able to better study galaxies around the Milky Way, further explore the composition of our own galaxy. In the ongoing exploration with the Parkes radio telescope, they discovered a cluster of galaxies, located on the other side of the Milky Way, known as the mysterious region of the Great Attractor. Although the Great Attractor is on the other side of the Milky Way disk, due to the high density of galaxies there, we cannot directly observe this area. This is because there is a large amount of material within the Milky Way, including planets, stars, gases, and dust. These materials are scattered throughout space. They block the light coming from further regions of the universe. Therefore, although we can easily map out most of the universe's structure, but when we try to observe our own galaxy, we are limited. When astronomers realize that due to the material within the Milky Way blocking, they cannot directly observe a specific area, they choose to call this area the zone of avoidance. This name may sound a bit exaggerated, but more importantly, the Great Attractor is hidden in this area known as the zone of avoidance. Inside now, do you understand why this strange gravitational monster has always been a mystery? Although sometimes, astronomers can gather some clues. But these clues are not enough to fully understand the nature of the Great Attractor. So, the Great Attractor pose a threat to our Milky Way and Earth? Constitute a threat? Although they all know our Milky Way and all galaxies in the supercluster are moving towards the Great Attractor, astronomers still do not understand what significance this has for us, and whether Earth is facing potential dangers. Some astronomers believe we need some time to fully understand what this unusual gravity is, while others believe this unusual attraction does not pose a threat to us. However, the question is, all galaxies in the universe are gathering into larger and larger superclusters. In the process of cosmic evolution, the formation of superclusters may be a crucial moment for the destruction of the universe itself. According to this theory, the universe may end before our Milky Way meets the Great Attractor, due to this strange force. Apart from the Great Attractor, dark energy on the largest scales in the universe is also a competitor threatening the fate of the Great Attractor. Dark energy. One of the reasons for the accelerated expansion of the universe is, the result of accelerated expansion is, galaxies far away from us are being pushed even farther, and their relative speeds are also increasing. The effect of dark energy is completely opposite to gravity. Gravity tends to pull matter together, while dark energy causes the acceleration of the universe's expansion, causing objects to move farther apart from each other. Although we can observe, the observable universe is filled with superclusters of galaxies, but from our perspective, these structures seem to be gradually disappearing. Furthermore, 13.8 billion years ago, the universe underwent a Big Bang. The event began filled with various forms of energy, including matter, antimatter, and radiation. Despite the occurrence of the Big Bang in the universe is filled with various forms of energy, but these energies are not distributed evenly like an ocean throughout the entire universe. Instead, in some regions, matter and energy are slightly higher, or slightly lower than in other areas. This leads to a competition in the universe. On one hand, the universe is constantly expanding, causing matter and energy to spread out, while on the other hand, gravity pulls all matter and energy together, forming clusters of stars. These clusters form. You might wonder, who will ultimately win this competition? In reality, both forces play a role, and there is no absolute winner. Under the influence of gravity, matter is attracted and gathers together, forming massive structures on a cosmic scale, like galaxies such as IC 1101, which have a mass equivalent to trillions of suns. In some regions of the universe, matter has a lower density, and these regions are known as cosmic voids. These regions have relatively less matter, causing the structures around them to be relatively denser. Therefore, cosmic voids are low-density regions relative to the surrounding areas. They also play an important role in the large-scale structure of the universe. Not only that, if there were no Laniakea, like the supergalactic cluster Kea and dark energy, our universe would fall into a state of disintegration. 5306. This is because dark energy is one of the main driving forces behind the expansion of the universe. It causes distant galaxies to move away from us at an accelerating rate over time. The existence of dark energy allows galaxy clusters to form and evolve, among which Laniakea Kea's supergalactic cluster is a key example. if there were no dark energy? Laniakea supergalactic cluster might not exist in its current form. Its galaxies and galaxy clusters would not be able to form. A massive cluster containing over 100,000 galaxies. Their galaxies and star clusters would be unable to form. A massive cluster containing over 100,000 galaxies. Therefore, dark energy plays a crucial role in the structure and evolution of the universe. Plays a crucial role. So without dark energy, our universe would not exist in its current state. So what do you think? Dark energy, is it possible? Affect the ultimate fate of our galaxy? Share your different opinions and views in the comments section. Thank you all for watching and paying attention patiently. See you next time.